Hi there, how are you today? Ready to learn something new? Okay, so today we'll learn two new terms of physics. One of the terms we usually use in our everyday life, but the other term is only specific to physics. We do not use it in our everyday life. Okay, so the first term is distance, and the second term is displacement. We say the distance from this city to that city is this many kilometers. We say the distance of our school from our home is this much, right? So this way, distance is a word commonly used in our everyday life. Okay, but the word displacement we do not use in our everyday life. This is specific to physics. It has a certain specific meaning in physics. So let's learn about these two words today, and let's see their differences. Okay, now let me take an example to explain the difference between them. Say a body was here at this point O, then it started moving in a straight line. It went this way, so it went 4 meters to in this direction, that is 4 meters. Then it took a left turn and it went this way for 3 meters. So it reached this point. So this is the original point and this is the final point. I calling it F. Okay. Now as per our everyday use of this word distance, if I ask you how much distance this body has traveled, what will you say? You will say it has traveled a distance of 4 plus 3, 7 meters. So distance covered by this body in everyday language is 7 meters, and in physics also the distance covered by the body is also 7 meters. So the meaning of distance or the meaning of distance covered by the body in everyday use and in physics is the same. It is the actual distance traveled by the body, or you can say it means the length of the path actually followed by the body. So here 4 meters, then 3 meters. So 4 plus 3, 7 meters is the distance covered by the body. In short, we say the distance here is 7 meters. Okay, so there is nothing much to learn here, very simple. Okay, now let's come to this word displacement. Let's understand what is displacement. Okay, this is a particular term in physics, as I said before. Now the first thing you should remember here is that displacement is a vector quantity. Okay, so since this is a vector quantity, it will have a magnitude and it will have a direction. Clear? So let's first talk about the magnitude of the displacement in this case. Okay, by definition, the magnitude of displacement is given as the shortest distance between the initial and final position. Okay, that means we can say it like this also. It is the straight line distance between the initial and final position. So this was the initial position, this is the final position. So if we join these two, remember body had moved this way, then this way. Initially it was here, finally it has reached this point. So the distance between the initial position and the final position, or the length of this straight line OF, is called the displacement of the body. Okay, so this doesn't depend on which way the body had traveled. Displacement only depends on the initial point and the final point. Okay, so length of this OF line, this will give us the magnitude of the displacement. Clear? Now what about its direction? The direction of displacement is from the initial position to the final position. That means in this case displacement is along this direction, along OF. Clear? So what we have learned till now? The displacement is a vector quantity. It has a magnitude it is a direction. Okay, the magnitude is given by the shortest distance between the initial position and the final position, and the direction is from the initial position to the final position. Clear? So displacement has both magnitude and direction, but this distance, it has only a magnitude. It does not have any direction. So we can say that the distance is a scalar quantity. You remember we had learned about scalars and vectors before, right? So since distance has only a magnitude, so distance is a scalar quantity, and since displacement has both magnitude and direction, displacement is a vector quantity. So this is the main difference between distance and displacement. Clear? Let's take another situation. So in this situation, say body was here at this point A, it moved 4 meters in this direction, then it moved in this direction for 5 meters, then it moved in this direction for 3 meters, so finally the body is here. Okay, so this is the final position of the body, let me call it F. In this situation, what is the distance covered by the body? Tell me. Try. Think. Okay, I think you have got the answer. The distance covered by the body will be 4 plus 5 plus 3. So 9 plus 3. 12 meters is the distance. Clear? And what is the displacement of the body? Displacement of the body will be length of AF. The length of this straight line will give us the magnitude of the displacement, and the direction of the displacement will be along this direction. Clear? Here I am not going to calculate the exact value of this displacement. I am just giving this example to show you the difference between distance and displacement. Okay, so here it was going from here to here, then here, then here. So distance is 4 plus 5, 9 plus 3, 12 meters. But the displacement is length of this, the shortest distance between the initial position and the final position. Direction is from initial to final. Clear? Good.